Hi students, the last videos application of derivative, the first part, the rate of change of quantity. Here in this part we discuss the increasing and decreasing functions. Using calculus, here verify the given function is increase or the given function is decrease, or find the intervals the function is increasing or the function is decreasing. It is clear? Increasing and decreasing function. Increasing and decreasing functions using the calculus. Here verify the function is increase or find the intervals the function is increase or the function is decrease or at a point. First we discuss the basic in algebraic definition of increasing functions and decreasing functions. Suppose y is equal to f of x is a real valued function. Y is equal to f of x is a real valued functions. Suppose you can say that or define in the intervals a to b, either closed intervals or open intervals in the intervals a to b. Y is equal to f of x is real valued functions defined on the intervals a to b. Suppose you can say that this one is the curve like this forms, or the curve is like this, or the curve is like this. It is a straight line parallel to x-axis. This type of curves. Suppose here define in the intervals x is equal to a and x is equal to b. Define in the intervals. Here also define this curve x is equal to a and x is equal to b. Here also suppose here define in the intervals this curve a to b. A to b. Here you know that this value is x0, this one is x1. You know that this value is x2, this value is x3. Continue like this. From left to right, the x values are increasing. It is clear? From left to right, here this one is origins. From left to right, the x values are increasing. x1 is less than x2, x2 is less than x3, x3 is less than x4. Suppose this one is xn, this value is x0. Assume that. Here also, this value is x0 and this one is x1. This value is x2. Here also x3. Here also x values are increases from left to right. Here also x0, this value is equal to. Here this one is x1, this value is equal to x2. Continue like this. This value is x3, this value is equal to xn. These are the curve y is equal to f of x. This one is the curve y is equal to f of x. This one is also a curve y is equal to f of x. This one is a straight line y is equal to f of x. The general. These type of curves. Here you know that the x values are increases. Here also x values are increases. Left to right you write increases. Here also x values are increases. Then find at the point x0 the value of this point. Here you can say that this one is f of a or f of x0. It's clear? Suppose this value is x1. This value is f of x1. This value is f of x2. F of x2. This value is here you know that f of x3. Clear? This distance is f of a. This distance is f of x1. F of x1. Is clear? This value is f of x2. This distance. This value is f of x3. This value is y1, y2, y3 like this. You can say that this value is equal to, at this point f of a, this value is f of x1. Suppose you can say that this value is f of x3, this value is f of xn. Clear? Here also this value is f of b, this value is f of x3, this value is f of x2, this value is f of x1, this value is f of a. Here all these values f of a or f of x1 or f of x2, this value is equal to f of xn. Just for the idea, algebraic forms or in geometrical way, you can say that suppose the x values increases, x increases, x0 is less than x1, x1 is less than x2, x2 is less than x3, x3 is less than xn. It is clear? Like this forms. Here x is increases. Here also x1 less than x2, x2 is less than x3 is less than, in this case is also, it means x value is increases. Then the value of f of a, the value of the functions at the point x equal to a. F of x1, the value of the functions at the point x is equal to 1. The value of the functions at the point x is equal to 2. This means this value is y0, y1, y2, y3. This value is yn. Here also you can say that y0, y1, y2. Suppose you say that y3 and yn. Y here, sorry, yn, no, yn minus 1, no, y3, y2, y1, y0. Here in all the case y0, y1, y2 up to yn. All the values are same. It means x is increases, the value of y. First y0, y1, y2, y3. Here you know that above the x-axis y values are increases, below the x-axis the y values are decreases. Here you can say that y is also increase. The value of the function is also increasing when x is increases. X increases, y is also increases. This type of functions, y is equal to f of x, is said to be increasing function. Increasing function. This one is increasing functions. X is increases, y is also increases. This function is y is equal to, you can say that this one is y is equal to f of x. It is clear. This function is increasing function. ಇದನ್ನ increasing function ಅಂತ ಕರಿತೀವಿ. x values increase ಆದ ಹಾಗೆ y values increase ಆಗ್ತಾ ಹೋಗಬೇಕು. Geometrically you can say that this curve is upward directions ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. It is a increasing functions, increasing curve from a to b ಅಂತ ಹೇಳ್ತೀವಿ. From a to b this curve is increasing functions. In this case x is increases. Here you know that y0, y1, y2, y3, yn. But y value is decreases. x0 ಇದ್ದಾಗ ಇಲ್ಲಿ x1, x0 is less than x1 plus, but f of x0 is greater than f of x1. x1 is less than x2, but f of x1 is greater than f of x2. It means x is increase, y is decrease. You know that from a to b the curve is downward directions ಅಲ್ಲಿ ಬರ್ತಾ ಇರುತ್ತೆ. It means it is a decreasing functions or decreasing curve ಅಂತ ಹೇಳ್ತೀವಿ. x increase ಆದಾಗೆ y ನು increase ಆಗ್ತಾನೆ ಹೋಗಬೇಕು, upward direction ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇರಬೇಕು from a to b ಕೊಟ್ಟಂತ ಇಂಟರ್ವಲ್ ಅಲ್ಲಿ. In a given intervals the curve is downward directions ಅಲ್ಲಿ ಬರ್ತಾ ಇರುತ್ತೆ. when x is increases, x increase ಆಗ್ತಾ ಇರಬೇಕು, y decrease ಆಗ್ತಾ ಇದ್ರೆ this function ಅನ್ನ decreasing, this function is said to be decreasing function. say that this one is a decreasing functions and this function is said to be increasing functions. ಇದನ್ನೇ ಡಿಕ್ರೀಸಿಂಗ್ ಫಂಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ, ಇದನ್ನ ಇನ್ಕ್ರೀಸಿಂಗ್ ಫಂಕ್ಷನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಇನ್ಕ್ರೀಸ್ ಮೀನ್ಸ್ ವೆನ್ ಎಕ್ಸ್ ಈಸ್ ಇನ್ಕ್ರೀಸಸ್ ವೈ ಈಸ್ ಇನ್ಕ್ರೀಸ್. ನಮ್ಮ ಕ್ಲಾಸ್ಗಳು ಹೆಚ್ಚಾದಾಗೆ ನಮ್ಮ ರಿಸಲ್ಟಿನ ಪರ್ಸೆಂಟೇಜ್ ಹೆಚ್ಚಿಗೆ ಆಗ್ತಾ ಇರಬೇಕು, ನಾವು ಇನ್ಕ್ರೀಸಿಂಗ್ ಫಾರ್ಮ್ನಲ್ಲಿದ್ದೀವಿ ಅಂತ. ಫಸ್ಟ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್, ಸೆಕೆಂಡ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್, ಥರ್ಡ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್, ಫೋರ್ತ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ classes are increases, then your annual results is also increase 80, 82, 90, 91, 92, 95, 96 like this forms. When x is increases, y is increases. Suppose you can take 1 to 12th standard. Here draw the curve. The class increases along the x-axis. First standard, second standard, third standard up to second PUC. Then here write the percentage. You get it is a increasing upward directions or downward. Suppose here class is increases. First standard, second standard, third standard up to 12th standard. Suppose you can take the intervals. Then the percentage suppose is decreasing. Suppose the percentage is decreasing, then you say that this one is a decreasing forms. The curve is always downward directions. Illi first standard, suppose you can say that in first standard is 80%, second standard 90%, second standard 85%, third standard 75%, like this. The curve is decreasing, always downward directions. This function is said to be a decreasing functions. Suppose the stagnation, ಒಂದೇ ರಿಸಲ್ಟ್ ಇರುತ್ತೆ, ಕ್ಲಾಸಸ್ ಆರ್ ಇನ್ಕ್ರೀಸಸ್ ಬಟ್ ಪರ್ಸೆಂಟೇಜ್ ಈಸ್ ಕಾನ್ಸ್ಟೆಂಟ್, is 90% is all the class 90%. You can say that this one is a constant functions. Stagnations ಒಂದೇ ರೀತಿಯಲ್ಲಿ ಇರುತ್ತೆ. It is a straight line parallel to x-axis. The y value is always constant. It is said to be a constant functions. Neither increasing nor decreasing functions is a constant function ಅಂತೀವಿ. In suppose some results like this in sometimes is increases and sometimes is decreases. In the intervals you can A and B. In the intervals A to B. Suppose first standard you can take in 12th standard. Sometimes it is increasing. 1 to 5th is increase. 5th to 8 is decrease. And in sometimes you suppose here you can take that this value is x equal to b is decrease. Against this value is increasing. In totally A to B, this function is neither increasing nor decreasing functions, but it is increasing in some interval, decreasing some interval and increasing in some intervals. Suppose this function is always increasing, it is said to be monotonically increasing in whole domain of the given functions. It is decrease is always, it is said to be monotonically decreasing functions in whole domain. Suppose it is always stagnations, then you say that it is a constant functions. Both are there in the intervals, in defined in the intervals is neither increasing nor decrease, because in some intervals A to C is increases, C to D is decreases, D to B is increases. But you can take in the intervals A to C, you say that it is increasing functions. C to D, it is downward directions, therefore it is said to be a decreasing functions. It's clear? This one is the geometrically you can say that the function is increase. Increase means when x is increases, y is also increase. And x is increase, y decrease, then you say that is a decreasing functions. X increases, y is constant, is said to be a constant functions. And you can write in geometric algebraically. This one is the geometrical way, you can say that. Here in generally you can say that x1 and x2, these two are the any arbitrary values belongs to the intervals A to B. Suppose in the closed intervals or in the open intervals, it belongs to A to B. Suppose you can take in open intervals A to B, including A and B. It is not down. x1 and x2 is belongs to the intervals A to B. These are the arbitrary values. If x1 is less than x2, here you know that x1 is less than x2, then f of x1 is also less than f of x2. F of x1 is less than x2. This value is f of x1. Here you know that this value is f of x2. F of x1 is less than f of x2. It's clear? Here you can take the values. This one is the curve. Here x1 and x2. Only you can taking the 2 points x1 and x2. It is belongs to the intervals a to b. Here x equal to a, x equal to b, x1 and x2. What is the value of f of x1? This value is f of x1. This value is equal to f of x2. Here you know that x1 is less than x2. x1 less than x2, then you taking f of x1 is also less than f of x2. Here x1 and x2 are arbitrary values. Here this value is x1 and this value is x2. You can taking any 2 points belongs to the intervals a to b. x1 less than x2, then find the value of f of x1 and f of x2. These two values also satisfy f of x1 less than f of x2. Then this function y is equal to f of x is said to be increasing functions in the intervals a to b. It is an increasing functions in the interval. This one is the definitions, algebraic definitions. Y is equal to f of x is a real valued functions defined on the intervals a to b. Defined in a closed interval is also in the intervals a to b. Then you can take in, it is the closed intervals. x1 and x2 you can take in the 2 points x1 less than x2. It is the arbitrary values. The similarly in decreasing functions, here also you say that this value is equal to f of x1 and this value is equal to f of x2. f of x1 value is this value is f of x2, defined in the closed intervals. Here a to b, a in the b ವರೆಗೂ you define ಮಾಡ್ತೀರಿ. This value is equal to, here also you can say that y is equal to f of x is a real valued functions. Y is equal to f of x defined on the closed interval or open intervals a to b. You can take in x1 and x2 are any points in the intervals a to b. If x1 is less than x2, x1 clearly less than x2, then f of x1 greater than f of x2. f of x1 greater than f of x2 is said to be a decreasing functions. x1 less than x2 agide, f of x1 is greater than f of x2. Here f of x2 is less than f of x1 ide. Therefore this function is said to be, then y is equal to f of x is said to be a decreasing functions. Decreasing function, ಇದನ್ನ decreasing function ಅಂತ ಕರಿತೀವಿ. It's clear? Suppose this value is x1 is less than x2, but f of x1 is equal to f of x2. For each x1 and x2 is belongs to the intervals a to b, then this function is said to be constant function. ಇದನ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಫಂಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಒಂದೇ ಲೆವೆಲಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂಸಲ್ಲಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಇದು ಆಲ್ಜಿಬ್ರಿಕ್ ವೇದಲ್ಲಿ ಹೇಳ್ತೀವಿ. ಇಲ್ಲೇ ಕೆಲವು ಡಯಾಗ್ರಾಮ್ಸ್ ಬರುತ್ತೆ. ಇಟ್ ಈಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಮೀನ್ಸ್ x1 ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ x2 ಇದ್ದಾಗ f of x1 ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ f of x2 ಆಗಿರಬೇಕು. ಇಟ್ಸ್ ಕ್ಲಿಯರ್? ಈಸ್ ಸೆಟ್ ಟು ಬಿ ಇನ್ಕ್ರೀಸಿಂಗ್ ಫಂಕ್ಷನ್ಸ್, ಇಟ್ ಈಸ್ ಸೆಟ್ ಟು ಬಿ ಡಿಕ್ರೀಸಿಂಗ್. ಇದು ಸ್ಟ್ರಿಕ್ಟ್ ಆಗಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದ್ರೆ ಸ್ಟ್ರಿಕ್ಟ್ಲಿ ಇನ್ಕ್ರೀಸಿಂಗ್ ಫಂಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಸ್ಟ್ರಿಕ್ಟ್ ಆಗಿ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದ್ರೆ ಡೌನ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಬರ್ತಾ ಇದ್ರೆ ಇದನ್ನ ಸ್ಟ್ರಿಕ್ಟ್ಲಿ ಡಿಕ್ರೀಸಿಂಗ್ ಫಂಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಇಟ್ ಮೀನ್ಸ್ y is equal to f of x. So in some graph like this, suppose the graph is this one is suppose here and like this, or graph like this, or the graph this way, or you can say that graph is this type. These are y is equal to f of x, real valued functions defined on the intervals a to b, either closed intervals or open intervals. Here you can taking x1, here x2, or ಎಲ್ಲಿ ಬೇಕಾದರೂ ತಗೋಬಹುದು x2, or here x2, or in this case ಇಲ್ಲಿ ತಗೊಂಡಾಗ ಸಪೋಸ್ x1 ಇಲ್ಲಿ x2 ಇನ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟು ಇಲ್ಲಿ ಇದ್ರೆ, ಇಟ್ಸ್ ಕ್ಲಿಯರ್? ಹಿಯರ್ ಯು ನೋ ದ್ಯಾಟ್, or you can taking this one is x1, in x2. It is the arbitrary values defined in the closed intervals a to b. Here also, suppose this one is x1, no? Here x2 ಇರಬಹುದು ಅಥವಾ ಇಲ್ಲೆಲ್ಲೋ ಇರಬಹುದು ಅಥವಾ x1 and x2 ಇದು ಪರ್ಟಿಕ್ಯುಲರ್ ಕೇಸ್. Or this one is x1, no? This value is x2, defined in the intervals, in a given intervals. Here you know that x1 is less than x2, y is equal to f of x, and x1 and x2 are any two points in the intervals a to b. Is clear? If x1 is less than x2, or suppose here taking here x1 and x2, x1 is equal to x2, both are exist. x1 is less than x2 ಅಥವಾ x2 ಆಗಿರಬಹುದು. It is clear. In this case, here strictly is less than x2. If in this case f of x1 and x2 are any two points in the given intervals a to b. If x1 is less than x2, x1 is less than x2, x1 less than x2, ಇಲ್ಲಿ ತಗೊಳ್ಳಿ ಇಲ್ಲಿ ಬೇಕಾದರೂ ತಗೋಬಹುದು. x1 ಇಲ್ಲೇ ಇರಬಹುದು, then x1 is less than x2. x1 ಇಲ್ಲಿರ್ಬೋದು, x2 ಇಲ್ಲಿರ್ಬೋದು, x1 ಇಲ್ಲಿರ್ಬೋದು, x2 ಇಲ್ಲಿರ್ಬೋದು, then x1 is less than x2 ಇರುತ್ತೆ. But x1 is less than x2, then f of x1 is less than f of x2 ಆಗಿರಬೇಕು. x1 x2 ಇಲ್ಲಿ ತಗೊಂಡ್ರೆ f of x1 less than x2, this f of x1 ಇಲ್ಲಿ ತಗೊಳ್ತೀರಿ ಅಥವಾ ಇಲ್ಲಿ ತಗೊಳ್ತೀರಿ f of x2. It is clear? f of x1 is less than f of x2, or suppose at this place you can taking x1 and x2 are the arbitrary values, x1 less than x2, then f of x1 values, this values both are same, f of x1 is equal to f of x2 here. In this case, suppose taking up to this point to this point, x1 is less than x2, you can taking any two points, f of x1 is equal to f of x2. Therefore, you can say that in generally in total curve defined in the intervals a to b ಅಂತ ನಾವು ತಗೊಂಡ್ರೆ, in the intervals a to b, x1 and x2 are any two arbitrary values. If x1 is less than x2, f of x1 is less than f of x2, f of x1 is less than f of x2 or equal, then you say that y is equal to f of x is increasing functions. This one is said to be increasing functions. It is clear? And suppose a to b, here you know that x1 is less than x2, then f of x1 is strictly less than f of x2. ಎಲ್ಲೂ ಈಕ್ವಲ್ ಅನ್ನೋದು ಬರದೇ ಇಲ್ಲ, ಇದನ್ನ ಸ್ಟ್ರಿಕ್ಟ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಅಂತ. Increasing functions, strictly increasing functions. It's clear? x1 is less than x2, f of x1 is less than f of x2, then it is said to be a strictly increasing functions. In this case, x1 is less than x2, x1 is less than x2, ನಾವು ಎಲ್ಲಿ ಬೇಕಾದರೂ ತಗೋಬಹುದು a to b, ಇಲ್ಲಿ a ಇದೆ ಇಲ್ಲಿ b ಇದೆ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ರಿ, ಡಿಫೈನ್ ಇನ್ ದ ಇಂಟರ್ವಲ್ಸ್ a to b ಅಂತ ನಾವು ತಗೊಂಡ್ರೆ x1 is less than x2 ಇದೆ, but here you know that this value is f of x1, no, this value is f of x2 values, or in this case f of x1 is equal to f of x2. ಇದು ಸ್ಪೆಷಲ್ ಕೇಸ್ ಅಲ್ಲಿ ತಗೊಂಡಾಗ if f of x1 is clear, x1 is less than x2, f of x1 is greater than or is equal to f of x1 greater than x2, or f of x1 is equal to f of x2, then f of x is said to be decreasing functions. Similarly, x1 is less than x2, but f of x1 is greater than f of x2, strictly greater than f of x. F of x1 greater than f of x2, then this function is said to be strictly decreasing functions. Strictly decreasing functions, strictly increasing functions and strictly decreasing, increasing and decreasing. These are the geometrically or algebraically definition of increasing, decreasing, strictly increasing, strictly decreasing functions. ಇದು algebraically and geometrically ಹೇಳ್ತಾ ಇರೋದು. Is increasing functions or strictly decreasing functions, or strictly decreasing functions. The next definitions is the basic definition of increasing and decreasing functions. Similarly, y is equal to f of x is defined in the open intervals a to b, and x is equal to c is belongs to the intervals a to b in the domain of the given functions. It is clear? In the domain of the given functions. The first one, suppose here curve is like this, or curve is, or you can write this way or this way, or the curve is like this. These are the different. Y is equal to f of x, it is a continuous curve. At the point x is equal to c, c is any point in the intervals. You can taking h is a small positive quantity, very small positive numbers, h. Here x is belongs to the intervals a to b, is the arbitrary values. X is equal to c is an arbitrary values in the intervals a to b. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ x is equal a ಆಗಿರುತ್ತೆ, ಇದು b. At this point a and this point is b. Here also at the end points you can say that a and b. You can define the intervals a to b, and c is a point inside ab. X is equal to c. This one is the c. H is small positive quantity. It's clear? You can taking the neighborhood point. I means the open intervals c minus h to c plus h. You can taking the neighborhood. C minus h means the left hand side of c. This one is c minus h. Greater than c plus h. H is very small. Then these are very close to c neighborhood point. You can taking x1 and x2 are any two elements in the open interval c minus h to c plus h I. If x1 is less than x2, if x1 is less than x2, then suppose f of x1 is less than f of x2. F of x1 not equal, strictly is less than f of x2, then you say that at the point x equal to c, f of x is increasing functions. Increasing. And this point c is called point of increases. ಇದು increasing point ಅಂತೀವಿ, c ಅನ್ನ point of increase ಅಂತ ಹೇಳ್ತೀವಿ. ಈ ಸಿ ಅನ್ನುವಂಥ ಪಾಯಿಂಟಲ್ಲಿ ಅಟ್ ದ ಪಾಯಿಂಟ್ ಎಕ್ಸ್ ಇಕ್ವಲ್ ಟು ಸಿ, ದಿಸ್ ಫಂಕ್ಷನ್ ಈಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಫಂಕ್ಷನ್ ಅಂತ. ಅಂದರೆ ಏನು, ಯು ಕ್ಯಾನ್ ಟೇಕಿಂಗ್ ದ ನೇಬರ್ಹುಡ್ ಪಾಯಿಂಟ್ಸ್ ವೆರಿ ಕ್ಲೋಸ್ ಟು ಸಿ. ಒನ್ ಈಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್, ಅದರ್ ಒನ್ ಈಸ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್. x1 less than x2 ಇದ್ದಾಗ f of x1 less than f of x2, again by definitions you say that increasing functions, increasing in the interval c minus h to c plus h. c minus h and c plus h are very close to c, the neighborhood, because h is a small positive quantity. It means in left hand side of the point c, this function is increase, and right hand side of c it is increasing. Then you say that at the point x is equal to c, the function is increasing functions. At the point x equal to c, the function is increasing. Similarly here in this case you can take c equal to this point. Here also you can taking the neighborhood point c minus h and c plus h. Clear? C minus h to C plus h. Here also x1 and x2 is belongs to the interval size C minus h to C plus h. It is clear? C minus h to C plus h. F of x1 is greater, is less than, here it is greater than f of x2. Here you can say that x1 is less than x2. Remember, x1 is less than x2 if then f of x1 is greater than f of x2. F of x1 is greater than f of x2, then at the point x is equal to c, the given function is decreasing. Point decrease. ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಈ ಫಂಕ್ಷನ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ ಅಂತ. At a particular point, you say that it means at this point you verify is increasing or decreasing. It is increasing, left hand side increase, right hand side is also increase. It decrease means in left hand side of C is decrease, right hand side is also decrease, then you say that this function is decreasing functions. At the point x equal to C is a decreasing point. Here at x equal to c is a increasing point. The function is increasing at a particular point. The function is decreasing at a particular point. And suppose at this point you can take x is equal to c. C is the point, belongs to the intervals a to b. Here you can taking the neighborhood point c minus h. And here you can take the c plus h. It is very close to c as h tends to 0. Here also you can take x1 and x2 is belongs to the interval psi. If x1 is less than x2, then both are exist. F of x1 is less than f of x2 and f of x1 greater than f of x2. Sometimes at this point you can take x1 less than x2, f of x1 is greater than less than f of x2. At this part x1 is less than x2, you can taking the 2 points, f of x1 is greater than f of x2. It means in either left hand side or the curve is like this. At the point x is equal to c, here c minus h, this value is equal to c plus h. In left hand side of this function is decrease, right hand side increase. Here left hand side increase, right hand side is decrease. Therefore at the point c is equal to 0, x is equal to c, this one is f of x is neither increase nor decrease. This point is called neither increasing nor decreasing point. Neither increase nor decrease. The function is increase function no alla, decrease function no alla. Okay? At the point x equal to c, the function is some decrease to increase change ಆಗಿರುತ್ತೆ, increase to decrease ಆಗಿ change ಆಗುತ್ತೆ. This one is called the point of neither increase or nor decreasing point. You can say that this point c is called the neither increasing nor decreasing point. Left hand side increase, right hand side increase, increase. At that point x equal to c is the increasing functions. Left hand side decrease, right hand side decrease. At the point x equal to c, the function is decreasing. Here neither increasing functions nor decreasing functions at the point x is equal to c. Neither increasing functions nor decreasing. Therefore point c is called the neither increasing nor decreasing point. It is clear? Neither increase. ಯಾಕೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಆಫ್ ಸಿ ಇಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿರುತ್ತೆ ಅಥವಾ ಡಿಕ್ರೀಸ್ ಆಗಿರುತ್ತೆ, ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಇದು ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಡಿಕ್ರೀಸ್ ಆಗಿರುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆದಾಗ ಇನ್ಕ್ರೀಸ್. ಇದನ್ನೇ ನೈದರ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ನಾಟ್ ಡಿಕ್ರೀಸಿಂಗ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ್ಯಂಡ್ ಒನ್ ಮೋರ್, ಸಪೋಸ್ ಹಿಯರ್ ಯು ಕ್ಯಾನ್ ಟೇಕಿಂಗ್ in whole domain, in a given domains, here verifying, suppose the function is the, you know that y is equal to e raised to x, so like this. The domain is the set of all real numbers. The curve is like this forms, or the log functions, the curve is like this forms. Or y is equal to, suppose you can say that f of x is equal to 1 divided by x. Suppose the x belongs to the domain of the given functions, the positive real numbers, or belongs to, that one is like this forms. In x belongs to negative real numbers, then you get like this forms. It is clear? It belongs to the domain. You can say that one is equal to, or y is equal to x, the straight line like this. Y is equal to minus x, the straight line like this. In whole domain, this function is always increase. In whole domain, this function is increase. X increases, y is also increasing. Upward direction is always increase. This one is in whole domain, the function is decrease. X increases, y value is decreasing. X increases, y is increasing. These functions are said to be monotonically increasing. Increasing or decreasing ಅಂತ ಕರೀತಾರೆ. ಇನ್ ಹೋಲ್ ಡೊಮೇನಲ್ಲಿ ಅದು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾನೆ ಇರಬೇಕು ಅಥವಾ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇರಬೇಕು. ಇಟ್ ಈಸ್ ಮೊನೋಟೋನಿಕಲಿ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆ್ಯಂಡ್ ಮೊನೋಟೋನಿಕಲಿ ಡಿಕ್ರೀಸಿಂಗ್ ಫಂಕ್ಷನ್ಸ್. ಇಟ್ ಮೀನ್ಸ್ ಸ್ಟ್ರಿಕ್ಟ್ಲಿ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆ್ಯಂಡ್ ಸ್ಟ್ರಿಕ್ಟ್ಲಿ ಡಿಕ್ರೀಸಿಂಗ್ the same in whole domain. Then you say that this function is increasing and decreasing functions. It is clear? These are the basic concept of increasing and decreasing. You know that in algebraic and geometrical way. ಇದನ್ನೇ ನಾವು ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಯಲ್ಲಿ ಯೂಸ್ ಮಾಡಿ ಡಿಫ್ರೆನ್ಸಿಯೇಷನಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ದಟ್ ಒನ್ ಈಸ್ ದ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಡೆರಿವೇಟಿವ್. ಹೌ ಟು ಅಪ್ಲೈ ದಿಸ್ ಒನ್ ಈಸ್ ಯೂಸಿಂಗ್ ಡೆರಿವೇಟಿವ್. ಯು ಕ್ಯಾನ್ ಸಾಲ್ವಿಂಗ್ ವೆರಿ ಈಸಿಲಿ verify the given function is increasing functions or decreasing functions or monotonically increasing or monotonically decreasing without draw the graph. ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ಬೋದು using the derivatives. Is application of derivative using increasing and decreasing functions. By one, you know that the increasing functions, you know that y is equal to f of x. This function is continuous and it is differentiable, defined in the intervals a to b, open intervals a to b. This function is a continuous function and this function is differentiable. It's clear? This function is increasing and verify this function is increasing, or find the conditions the function is increasing functions or function is decreasing functions using the derivatives. Here you can take in y is equal to f of x. Is continuous functions and it is differentiable in the intervals a to b. Here you know that h is a small positive quantity. You know that this function is increase means x1 and x2 is belongs to the domain of the given functions. x1 less than x2, then f of x1 is less than f of x2, then you say that the function is increasing function. Is clear? It is the algebraic definitions. Here also h is a small positive quantity, then you say that h is always less than x is always h is a small positive quantity. You know that x is always less than x plus h. It is true. Suppose the given function is increasing functions. Suppose y is increasing function. ಇದು increasing function ಆದರೆ x1 is less than x2, f of x1 is less than f of x2. It implies f of x plus h is greater than f of x. It means f of x is less than f of x plus h. It means f of x is x plus h is greater than f of x, or f of x is less than f of x plus h. It implies f of x plus h minus f of x is always positive. It's clear? Let us consider. We know that the definition of derivative, the limit of f of x plus h minus f of x divided by h as h tends to 0. Here you know that this value is equal to f of x plus h minus f of x. It is a positive, therefore numerator is positive. H is positive, therefore denominator is also positive, totally is positive. It is clear? This one is exactly definition of derivative. Differentiation of y with respect to x. It means f dash x, or write dy upon dx. This value is always positive, greater than 0 for each x belongs to the intervals a to b. Then you said that this function is increasing functions. This one is the conditions or the definitions of using derivatives. You say that this function is increasing functions, its derivative is always positive for each point with respect to x. You are differentiating y with respect to x. This value is always positive. Then you say that this function is increasing function. Very simple definitions. The given function is increasing means its derivative is always positive. Here also simply verify y is equal to f of x, continuous functions, and it is differentiable. H is a small positive quantity, then you know that x is always less than x plus h. Here suppose y is equal to f of x is decreasing. This one is a decreasing functions. Suppose you say that it is decreasing, it implies by definitions x is less than x plus h. X is less than x plus h, it implies f of x is greater than f of x plus h. It implies f of x plus h minus f of x is negative. You know that by definition of derivative, limit of f of x plus h minus f of x divided by h, as h tends to 0. It is differentiable means this limit is exist. Here you know that numerator is negative and h is a small positive quantity, denominator is positive, therefore this value is negative. It is exactly f dash x or dy upon dx. This value is always negative for each x belongs to the domain of the given functions defined in the open intervals a to b. It means suppose you get derivative is negative, the given function is said to be decreasing functions. The function is increasing, derivative is positive. The function positive, the function is decreasing, the derivative is negative. ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಡೆರಿವಿಟಿವ್ಸ್ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ, ಎಲ್ಲೆಲ್ಲಿ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ ಅಲ್ಲೆಲ್ಲ ಇನ್ಕ್ರೀಸ್ ಅಂತ, ಎಲ್ಲ ನೆಗೆಟಿವ್ ಬರುತ್ತೆ ಅಲ್ಲೆಲ್ಲ ಡಿಕ್ರೀಸಿಂಗ್. ಇಟ್ ಈಸ್ ದ differentiations method verifying the function is increasing and function is decreasing. It means strictly greater than 0 and strictly less than 0. You know that the derivative is 0. When the derivative is 0, dy upon dx or f dash x is equal to 0. This f of x is constant functions k. This one is a constant functions. Constant functions means it is a line parallel to x-axis. It's a constant values. X increase ಆದಾಗೆ y ಮಾತ್ರ same values ಇರುತ್ತೆ. It is said to be a constant functions. And this function is said to be neither increasing nor decreasing. It is a neither increasing nor decreasing functions. ಯಾವಾಗ derivative is 0 ಬಂತು ಅಂದರೆ for each x belongs to the intervals, or you can say that a to b, the derivative is 0, then you say that this one is neither increasing nor decreasing. ಒಂದೇ ಸ್ಟಗ್ನೇಷನ್ಸ್ ಆಗಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ ಅಂತ. ಇದು ಬೇಸಿಕ್ ಡೆಫಿನೇಷನ್ಸ್. ಹಾಗೆ ಸಪೋಸ್ ಯು ಕ್ಯಾನ್ ಸೇ ದಟ್ ವೆರಿಫೈಯಿಂಗ್ ಇನ್ ಎ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ದ ಫಂಕ್ಷನ್ ಈಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ ದ ಫಂಕ್ಷನ್ ಈಸ್ ಡಿಕ್ರೀಸಿಂಗ್. It's clear? Verify the function is increasing and the function is decreasing. ಇಲ್ಲಿ ಡೆಫಿನಿಷನ್ಸ್ ಏನಂತ ಹೇಳ್ಬೋದು, y is equal to f of x is said to be increasing functions. This one is said to be increasing functions in the intervals I. So that the definition, the first one, here the first case, y is equal to f of x is said to be increasing functions in the intervals I, then dy upon dx or f dash x is always positive for each x belongs to the interval I. It's clear? The second definitions, y is equal to f of x is said to be decreasing in the intervals I, then dy upon dx, or you can say that f dash x is always negative for each x belongs to the interval I. And the third one, y is equal to f of x is said to be constant function in the intervals I, then you said that dy upon dx or f dash x is always 0 for each x belongs to the interval psi. Constant means stagnations, neither increasing nor decreasing. ಇದು ಇನ್ಕ್ರೀಸಿಂಗ್ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನಲ್ಲಿ, ಡಿಕ್ರೀಸಿಂಗ್ ಡೌನ್ವರ್ಡು ಕಾನ್ಸ್ಟೆಂಟು ಸ್ಟ್ರೇಟ್ ಆಗಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಇದು ಡೆಫಿನಿಷನ್ ಆಫ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆ್ಯಂಡ್ ಡಿಕ್ರೀಸಿಂಗ್. ವಿ ಆರ್ ಯೂಸಿಂಗ್ ದಿಸ್ ಡೆಫಿನಿಷನ್ಸ್. ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಒನ್, ಹಿಯರ್ ಯೂಸಿಂಗ್ ದ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೇಸ್ or particular point, verify the given function is increasing or decreasing. Suppose y is equal to f of x is said to be increasing functions at the point x is equal to a. It is belongs to the domain of the given functions. Here verifying at a particular point, at the point x equal to a, the y is equal to f of x is said to be a continuous at increasing at x equal to a. Then you said that the derivative of y with respect to x at the point x equal to a is positive, or you said that f dash a is always positive. It's clear? The second one, y is equal to f of x is said to be decreasing at the point x equal to a. Then you said that the derivative of y with respect to x at the point x equal to a is negative, or you said that derivative of f of x at the point x equal to a is negative. Simple verify. You are verifying at a particular point, it is increasing at that point or decreasing at that point. Very easily find the increasing point or decreasing point, or verifying increasing or decreasing. Suppose here the third case, neither increasing nor decreasing, decrease to increase or increase to decrease, if f dash or dy upon dx at the point x is equal to a is 0, or f dash a is equal to 0. This one is the, then you can say that y is equal to f of x is either increasing or decreasing, or you can say that neither increasing nor decreasing. But this point x is equal to a is turning point. It means this point is turned to increase to decrease at the point x is equal to a, or this point turns to decrease to increase. You said that this one is turn at the point x equal to a, increase to decrease, or like this, this one is decrease to increase at x is equal to a, or this value is constant at x equal to a, neither increasing nor decreasing points. All these are neither increasing nor decreasing. Or sometimes here you get this value is like this, or this one is curved like this forms. At the point x is equal to 0, it turns the change. ಹೀಗೆ ಬರ್ತಾ ಇರೋ ಡೈರೆಕ್ಷನ್ನು ಹೀಗೆ ಹೋಗ್ಬೋದು, ಅಥವಾ ಹೀಗೆ ಬರ್ತಾ ಇರೋ ಡೈರೆಕ್ಷನ್ಸು ಹೀಗೆ ತನ್ನ ಡೈರೆಕ್ಷನ್ಸನ್ನು ಚೇಂಜ್ ಮಾಡಿರುತ್ತೆ ಅಂತ. ಅಟ್ ದಟ್ ಪಾಯಿಂಟ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ dy upon dx equal to 0 ಇರುತ್ತೆ. ಇಟ್ಸ್ ಕ್ಲಿಯರ್? ದಿಸ್ ಒನ್ ಇಸ್ ದ definitions of the function is increasing or the function is decreasing. Just you can verify. This one is y is equal to, one example, y is equal to sin x. Define in the intervals 0 to pi anta ತಗೊಳ್ಳೋಣ. Okay, 0 to 5. Already you know that this one is the curve sin x at this point pi by 2, 0, pi. Clearly from figure you can say that it is neither increasing nor decreasing in the intervals 0 to pi. In 0 to pi by 2 the function is increasing. In pi by 2 to 0 the function is decreasing. At the point x equal to 0 it is the turning point. Neither increasing nor decreasing point. We are verifying this one is using the definitions calculus methods. The given functions y is equal to sin x. Therefore, derivative of y with respect to x, you know that its value is equal to cos x. In first case, you know that for each x belongs to the intervals 0 to pi, you know that the value is like pi by 2, first quadrant. In first quadrant, cos x is positive. Cos x is always positive. It means dy upon dx is positive. It is clear? Therefore, this function is increasing. Here you can say that the first one, this functions 0 to pi sin x is increasing functions. Second case 0 to pi by 2 and pi by 2 to pi, you know that sine function is decreasing functions. This one is decreasing. Third one, at the point x is equal to pi by 2 sin x is neither increasing nor decreasing. It is clear? Therefore, this one is true, it is increasing by calculus method. This one is with the help of figure or geometrically. Suppose using calculus, for each x belongs to the interval 0 to pi by 2 cos x positive, because lies in first quadrant, dy upon dx is positive, therefore increase. The second case, for each x belongs to the intervals pi by 2 to pi, you know that cos x lies in the second quadrant is negative. It means that is dy upon dx is negative. Therefore, it is decreasing. It is clear. Next, the third case, x is equal to 5 by 2 dy upon dx. Cos x equal to 0. It means dy upon dx equal to 0. Therefore, you say that neither increasing nor decreasing. Suppose verifying at the point x equal to pi by 4. Here you know that cos pi by 4, this value is equal to 1 by root 2. It is positive. F dash x equal to. Therefore, increasing point at x is equal to pi by 4. It is increasing at the point of words. At the point x equal to 3 pi by 4. This one is clear at this point. F dash x at x equal to pi by 4. Suppose at the point x is equal to 3 pi by 4, f dash x, it means cos of 3 pi by 4, this value is minus 1 by root 2, this value is negative. Therefore, decreasing at x equal to 3 pi by 4. Is clear? Next, at the point x equal to pi by 2, you know that dy upon dx, it means cos pi by 2, its value is 0. Therefore, neither increasing nor decreasing. It is turning point. It means up to pi by 2, sine function is increased. After pi by 2, sine function is decreased. Therefore, this point is neither increasing nor decreasing. Or you get a turning point. The curve changes the direction, its directions. Increase to decrease or decrease to increase. Now, ಮುಂದಿನ ವಿಡಿಯೋದಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ನೋಡೋಣ. ಥ್ಯಾಂಕ್ ಯು.